So turn it over to page 117.
117啊。
大家唔好嘈住，跟住咧教完就揾就啦嚇。Turn your book to page 117. Okay, so do chapter 10 2C. So combine these three resistors. So combine these three resistors to find the equivalent resistance. Okay, so if both of them have resistance out,叫你揾個 resistance， 中文都冇話導電，你冇導電，你而家冇電線，你就冇 resistance。你見到啲題目要點做啊？都話你見到啲唔識嘅 circuit 要點做啊？
拆開佢。
你就當自己係 current 行一次啊嘛。咁你當自己係 current， 呢個係第一堂嘅講啦，我都冇做過呢。So you can choose either point to be the starting point of current. Okay, so I give you 2 minutes. Okay, so you try to find the path of current. Find the equivalent resistance. So that means the resistance after you combine these three resistors. so the graph is actually like this. Okay, so you can imagine if your current, then you can when you go to this point, then you may go up and down, right? So, but so you may think about that. Oh, it's quite weird, right? Because the lower part have no resistor. Then you suppose all the currents will go to the lower part, right? 咁點解唔係嘅 in this case?
因為佢仲有。
So even if the current goes to the lower part, then you need to choose either part at this point, right? So even the current chooses the lower part, it will still go the left resistor or this resistor. Okay? So for the current, no matter which part the current choose, it at least goes through one resistor. Okay? So if you choose the upper part, then you will pass through this resistor. And then you go to point B. So if you choose the lower part at this point, then you still need to choose one path to go, and then you will still pass through one resistor. So in this case, what is the equivalent resistance? What's the equivalent resistance for this case? What's the equivalent resistance for this case? Yeah. Okay, so actually, so if both of them are out, so they are connected in all three are connected in parallel. Okay. So for you to easier to understand, okay, so this may make you easier to understand. As you can see that all three resistors are just simply connected in parallel. Okay? So although the arrangement of these three resistors are quite weird, but actually they are same to the simple circuit for these three resistors connected in parallel. So the 1R equals to 1 over R plus 1 over R plus 1 over R. Okay. 咁咧，其實我應該唔會出啲咁奇怪嘅，不過咁呢本書有呢條題目㗎嘛，咁就講俾你聽咯。So you need to imagine that your current and then to pass through each path, and finally you will find that no matter which path you choose, then you will pass through one resistor at least. Okay, so that these three resistors are connected in parallel. Oh. 藍色嗰個咧行到嚟呢度咧，佢就唔會再向右行啦。點解啊？因為行到嚟呢度咧，佢行上面係咪即刻就到 B 啊？真係。係。咁佢行呢度咧，仲有 resistor， 所以佢唔會揀。咁點解 current 啫？有嗱，你睇落去咧，呢兩條路同呢兩條路咧，好似差唔多咁樣，係咪？點解一開始啲 current 啫會揀上面咧？有啲你可能覺得咧，全部應該都會揀下面，係咪？咁點解咧？就係因為佢揀下面嘅時候咧，其實佢嚟到呢度咧，佢左右都有 resistor 咯。所以咧，其實佢揀上面同下面係一樣嘅對啲 current 嚟講，因為佢最少都要經過一個 resistor。咁所以咧，嚟到呢度咧，即係喺呢個 point 即係上下都會有 current。但係咧，當 current 嚟到呢度嘅時候咧，佢就唔會再揀呢度啊？點解啊？因為咧，佢上面咧，佢唔使經過任何 resistor 就會翻到屋企咯。OK。
即係啲 current 會揀最少嘅 resistor 嚟行。
綠色嗰個其實都係咁樣行啫嘛，啲 current 咁樣行到嚟呢度都行穿咗。唔係唔一定嘅。點解佢一定要向住呢個方向行啊？冇關係。咁你好似啲其實佢係水嚟㗎嘛，咁你啲水都唔一定要向右行，係咪？即係咁你一條水管嚟到呢度分叉，咁就向左行啦。嚇？係 positive 同 negative 啊！嗱，譬如你當呢度係 positive，呢度係 negative，咁總之佢最後去到 negative 就得啦。咁佢而家行呢度都去到 negative，冇關係啊！即係我點行嘅啫。因為自己係水嘅話，寫住我對象，因為你行埋嘅嘢，你呢個唔知邊個去做。咁你翻到你最後之前你都會邊個去做？係啊，咁你行 A 都係邊個去做？所以咧簡單啲講咧，無論你點行，最後都係經過咗一個 resistor 咯 ，so that they are conducting current. Okay, so and there is another low B method to do this correction. Okay, so 我刮花咗佢，仲錄住咗我刮花咗。好啦，咁咧有一個好低 B 嘅方法嘅，就係呢個圖解法。嗱，如果咧你唔係好識畫啲 current 咧，其實咧你可以畫佢樣出嚟啦。你想象一下，你將呢個地方向上拉 ，OK， 咁個圖咧會變咗做咩樣啊？個圖會變咗做咩樣啊？即係你將條線咧向上扯，咁咧個圖係咪變咗咁嘅樣啊？係咪？只不過係將呢度咧向上掹一掹，呢度向下一掹掹，咁個圖係咪變咗咁嘅樣啊？係啊。你再努力掹一下，你再喺呢度咧向上掹一下，呢度咧向下掹一下。啊！你啲想像力咧要比較豐富啲嘅，會。咁咧個圖就變咗咁樣。So it's obvious that it's connected in parallel。你諗下呢度再向上掹，呢度再向下掹，呢個係咪變咗打直咁啊？係啊，跟住呢度又變咗打直，呢度咧又係打直，咁咧最後個圖就會變咗咁樣。所以咧，雖然佢畫到咁樣，其實咧嗰個 graph 咧係 equals to 3 resistors connect in parallel. Okay? So normally, if you take the IGCSE and IELTS, you will see this kind of circuit. But if you want to take the Taiwan entrance exam, then you may see something like this. Okay? 淨係台灣先會出啲咁離奇嘅嘢，其他都唔會有機會。咁咧你抄咗翻去，慢慢再諗啦，唔明就 inbox 我啦。Okay, so now so for the last 2 periods, I taught you how to find the voltage and current of each resistor, right?
Yes.
So there is one thing we can find of the resistor, so which is the energy consumed of the resistor. Okay? So for example, so let's do the easiest case. So give you 5 seconds. So what's the voltage and current across the resistor? What's the current across this resistor?
10.
And so what's the voltage across this resistor?
10.
10. So what is the power consumed by this resistor? So the resistor will use the energy, right? So how much energy is used in 1 second? So when you are in Form 3, so you learn the equations about power. So what's the equations of power? So the power equals to the energy over times, right? So and actually you have learned about the energy provided by the power supply. Do you remember that? When we first define the voltage or the electromotive force, we have linked the voltage with energy. Do you remember the equations?
No.
So what's voltage? Voltage equals to,
Equals to IR.
not IR. I mean to link the voltage with the energy. What's the equation? The voltage equals to energy over charge. So do you remember this equation?
So
So it's the equations when we first define the voltage. Okay, so which is on which is on page 86. Page 86. Page 86. And sure see this equation, right? So we arrange
86嗰度。
rearrange the equations. That should have energy equals to the charge times voltage. Okay? So power equals to charge times voltage over T. So are you okay with that? So this doesn't matter, you just forgot this equation. But I just told you there is the equations to link the energies and the voltage, okay? So the first time I tell you why the higher the voltage, the higher the energy is linked to these equations. Do you remember that? Okay, so when the charge passes through the power supply, then it can gain energy. Okay, so what is Q over T? What is Q over T?
T
What is Coulomb over T?
I
Yes, so it's equals to I. So actually, the power consumed by the electric component equals to VI, okay? So this is the equation for you to find the energy consumed by the electronic device in 1 second, okay? So and you can transform these equations into 3 different forms. So since V equals to IR, right? So since V equals to IR, so this equations can be rewrite as this. Okay, so which is I squared out. Okay, or so you can replace the out. You can replace the out as V equals out. Okay, since V equals to I out, then she can rearrange the equations as I equals to V over out. Then she will get these equations V squared over out. Okay, so finally, then she will get the 3 forms of power. So P equals to VI equals to I squared out equals to V squared over out. Okay, so you will find the same values by using these 3 equations. Okay, so for example, what is the voltage? What is the voltage of consumed by this resistor? It's 10, right? So let's try the first equation. So P equals to VI. So the power consumed equals to 10 times 10, so equals to 100. So what is the unit of power?
Watt
Watt, OK？ 咁咧就即係佢每秒咧就會用咗100 Joule啦。呢個 watt 咧就即係 Joule per second 係嘛？咁你點樣計一個電器或者一個 resistor 咧每秒用幾多 energy 咧？咁就可以用呢個 P equals to VI 或者用乜嘢啊 ？P equals to I squared out. OK? So what is I squared? I squared is 10 squared, right? Times R, so R is 1, so equals to 100 volts. Okay? So P equals to V squared over R, so 100 over 1, so it still equals to 100 volts. Okay? So this is the equations for you to find the power consumed by one resistor. Okay? So actually, how can you know how much energy your iPhone or the air conditioner is consumed? So if you know the if you know the resistance of your device and you know the voltage supply, actually you can find energy consumed of the electronics device. Okay, so just using this equation. 咁所以咧，其實咧同我哋之前學嘅基本上冇分別嘅，因為咧你哋而家應該可以揾到任何 circuits 嘅 V 同 I of each resistor， 係咪？咁咧你就用你揾到呢個 V 同 I 之後咧，如果題目叫你揾個 power 咧，咁你代翻公式就搞掂。所以基本上咧你冇學過任何新嘅嘢，咁你就學多咗一條 equation。咁如果人哋叫你揾 voltage、current and power of each resistor， 咁你就寫埋個 power 出嚟。Okay, so I give you the remaining time to finish your file. Okay, so if you so want to ask any questions about this lesson, then you can raise up.